Okay, is the mic on? Can you hear me in the back? Yep. Okay, good. So, again, a reminder, you're going to get this every time. I apologize, but it's worth coming to, so I'll just keep it in mind. QR code in the corner. I'll post it on Icon as well. Okay, so Lab 2 was yesterday. Some of you struggled with Lab 2. We're going to talk about it today. That's okay. Struggling is part of the expected experience. So one thing we need to get straight, though, is please don't email me your stuff. You know, I literally have 15,000 emails in my inbox. I'm not going to be able to handle everybody's submissions individually, download them, deal with them, and grade them. I can't do that. It's not going to happen. That's why we have Icon. The labs are due by the end of the lab period. There's a 5-minute grace period. Some of you are trying to turn things in 10, 15 minutes late, and it's closed. And the reason it closes is because we need people to move out of the lab so the next class can move in and have their turn. So these things are timed mostly because of the physical constraints in the lab. My advice to you is that as you work through the lab and you get one of the problems done, upload it. You can upload many times, multiple times. We'll only grade the last one uploaded. So please don't email me your stuff, and don't tell the TA, Icon failed. Icon didn't fail, you're late. So just get it turned in before the end of the lab. It is okay if you don't do all the problems in the lab. Labs are challenging. You may not get to every problem. That's okay, it's a learning experience. But don't wait to turn it in and then say, I couldn't turn it in, you need to take it now. I can't deal with all those labs one at a time. So Lab 2 will be graded by the end of the day. Actually, it's grading now, so should be able to produce those by maybe half an hour after the end of class. Question day 3 was graded on Monday. Question day 4 will be released after class today. There will be a question of the day 5 on Friday. I haven't decided if there will be a question of the day 6 on Monday yet, and we'll get to that in just a second. So please, I get a lot of kind of desperate emails. People are stressed out about their grade and about not being able to do all the problems. There are very few 10s in the labs. Very, very few. 10 is really outstanding. If you got every one of the problems on Lab 2, pat yourself on the back. Good for you. Most of you won't. That's okay, right? Not everybody is excellent. We're all learning. So the average is going to be somewhere in the 4 or 5 point range, maybe 6. That's okay. I don't want, I get a lot of notes. I'm worried about the final exam. Dude, we haven't even gotten to the first midterm yet. So relax. Focus on what we're doing in class. You'll get the hang of it. CS1 is a weird experience. The weird experience is that a lot of people really struggle at the beginning. It's alien to you. We're asking you to think in a way that's not natural to you. It may be revising your expectations about your self-image. Some of you have a lot of coding practice. That doesn't mean that that practice is useful in this class, because I'm trying to train you to think about problems and approach them in a different way. So you may find that that's at odds with what you've been doing, maybe with some great success up to now. That's okay. I hope that what happens in this class is that you see and appreciate other ways of dealing with problems, and that in the end it will make you a better coder, or into a strong coder, if nothing else. So this is all part of the journey we're on, right? It's okay not to always be successful. That's how you can learn. Now, the book has problems in every chapter. Some of those problems will parallel the material we're doing in class. Some of them won't. But they're all useful problems. So let's talk about exams. We will have the first midterm actually a week from today. It's going to take place in class, so you can't afford to be late. It's 50 minutes long. In the past, this class has had evening midterms that were an hour and a half or 2 hours long. We're not doing that this year because it's hard to get a room. They schedule rooms on weird nights. Sometimes they shift things by a week. So we're just going to, instead of having 2 midterms, we're going to have 3 shorter exams in class. The final will also happen. That'll happen in a different room at a time the university decides. So we'll talk about the midterm, not today. but on Friday and Monday. But I will give you some pointers for reviewing for the midterm before the midterm. Midterms 2 and 3 are tentatively scheduled for these dates. You'll notice they're all Wednesdays. The reason they're Wednesdays and not Fridays, as I originally intended, is that the TAs are free to come and help proctor on Wednesdays, but not on Friday. So I have to accommodate their class schedules as well. I think these are pretty firm dates. Certainly next Wednesday's is. For those of you who have submitted your SDS accommodations, I'm struggling with the proctoring system on ICON, but essentially what will happen is you should get notified by me that your exams are to be taken within a window of exam time at the student exam testing center, and you'll have to sort of register for it through ICON. I don't have all the details yet. This is the first time they've used this system, or I've used this system. But I think it's going to work out okay. And I do know who you are because I've already seen your SDS accommodations. I will confirm with you individually. So let's all take a collective deep breath. This is hard. Becoming a good coder takes practice, and it's not practice just in coding, although that's part of it. Certainly knowing the syntax and having at your fingertips sort of the knowledge of what the library of functions that are built into Python are and when to use the appropriate one, that's all good stuff. But it also takes practice in thinking about how to approach a problem. So many of the students I've talked to or I've helped sort of get on the track of doing the problem this way, and it doesn't quite work, so they try to patch it, and then they try to patch it again. And pretty soon, they've done so much work and they've built this really Baroque construction. Everybody knows what Baroque means? Yes? No? Who can tell me the dates of the Baroque period? That's a liberal arts school, you should know. No music majors? We had one, didn't we? Yeah.
I know it was like 1700 something.
Yeah, so it's the same dates as Bach's birth and death, 1685 to 1750. The only thing I remember from music history, but there it is. So you all learned something today. But it happens in coding too. Baroque is like ornate and frilly and complicated. We're not shooting for ornate. We're shooting for clean, minimalist, and simple code. That's what, in my opinion, makes code more maintainable and more useful and less error prone. So if you're using, on the question days and labs, if you're using constructs we haven't used in class, you're probably doing it wrong. So I noticed in the lab yesterday there were a couple of for loops. We haven't talked about iteration. There's been no iteration in this class so far, and there won't be till after the midterm. So if you're using for loops, you're fitting a square peg in a round hole. That's what you're really doing. So my advice to you, reread the assigned readings. Every time you look through those pages, you will pick up another construct that we may or may not have talked about in class. But as you work problems, you'll say, oh gosh, I could have used dot upper for strings. So that's the way you're going to sort of assimilate enough Python in a short period of time to be really useful. Ask questions. Piazza, there's a lot of activity on Piazza. Can't tell you how many questions I've answered, but it's in the hundreds. So, use Piazza, post your questions, get a discussion going with your classmates on Piazza. You can help each other get through this. Okay, let's talk about the lab. So the first problem was the easiest one in the lab. So it takes a sequence of sequences where S may be either a tuple or a list, and each element of S is itself a sequence of numerical values, which could be a tuple, list, or range. So notice the restriction is ordered in a sequence. It has to be a tuple or a list of other tuples, lists, or ranges. It can't be a range of other ranges because you can't bake that data structure. It has to be a tuple or a list containing itself tuples, lists, or ranges. And all of the elements in here are numeric. Everything's a number. There was a hint telling you to look at map, max, min, and sum in chapter 10 from the readings. Let's talk about those. Max is a function that takes a sequence of integers or numbers, a numeric sequence, and returns the element that has the maximum value in the sort of obvious way. The other ones work the same way. Min returns the minimum value. Sum returns the sum of all the elements in the list. Now, the one that is a little bit different is this first one, map. And we're going to see a different mechanism. We're not going to use map much. In fact, I don't use map at all. I use a different construct other than map. But it's useful to see map because it's concise and it's simple. What map does is map takes a function name, this is sum, which is one of these functions, and applies it to every element of the sequence, which is its second argument. So we take the sum function and we apply it to 1, 2, 3. We apply it to 3, 4, 5. We apply it to 5, 6, 7. And we return this funny map object. Good Lord, what do you do with that? Well, I want to point out that map works over sequences like tuples, lists, and ranges, right? So what it returns is not necessarily a tuple, list, or range because it could work on any of them. So what it returns is it returns this thing called a map object, which has this funny printed representation. But the cool thing is I can put that in a list statement. Remember what list does? It's the thing that changes the type. So if I take a tuple and I pass it to the list argument, that tuple becomes a list. If I take a list and give it to tuple, it becomes a tuple, and so on. So we've seen this, for example, list of range takes that range representation and blows it up into a list so you can see what's in it. So I'm just going to take this map of the sum over these, turn it into a list, and I get back a list of the sum of 1, 2, 3, the sum of 3, 4, 5, and the sum of 5, 6, 7. So what a handy thing, right? One little function lets you take a function and apply it repeatedly to a bunch of things in a sequence. So my solution now is quite simple. I'm going to take the max function, map it onto S. That'll give me the maximum value in every subsequence of S. And then what I do with that is I turn it into a list. I can do this on ranges. This is a tuple of ranges. And that'll give me 7 minus 6 and 97. And so on. So this is the straightforward implementation of map element. One line. Just one statement. Two functions. So those of you who approach this with for loops, nested inside for loops, aside from the fact that this is what you've been taught in other programming classes because you had for loops, and that's how people teach Java or C or whatever. Compare your solution with that. That's really elegant, it's simple, it's clean. It's mid-century modern, isn't that the thing now? Is that the big deal, mid-century modern? My younger daughter's obsessed with mid-century modern. I was alive the first time, I'm not obsessed with it. It evokes to me shag carpet, crappy little coffee tables, but she loves this stuff. Anyway, so there you go. Straightforward, simple, clean. That gets full credit. Second one, sub-center. So we've been doing a lot of slicing and dicing. It's because I think slicing and dicing is really important, and you need not just to understand it, but you need facility with it. You need to sort of have that language at your fingertips. So I'm giving you a lot of these problems with funny corner cases so that you're forced to confront your understanding of what the semantics of a slice really are. So we take a tuple of integers, t, and return a new tuple that contains all the elements of t, except that it replaces the centermost element with multiple copies of the smallest element in t, where the number of copies inserted corresponds to the maximum or largest element of t, or 0 if that element is less than or equal to 0. Holy smokes. That's a lot of language. First of all, you got to sit down and understand this. So when I'm faced with something like this, I usually, and I think there was a hint here that says you will need to use an if statement. That was in the, so I sit down and say, okay, well, I'm going to write this with 3 ifs, because every one, or 2 ifs actually, every one of these, this outlines a special condition. Empty tuple has no center element, so I don't know what to do with that. If the maximum tuple, the maximum element of tuple is less than or equal to 0, here, I'm going to do something else. And otherwise, this is sort of the general case. And each one of those pass statements, remember the pass is a placeholder, so I can make my function and sort of, I'm designing this function from the top down. I'm mirroring the spec and breaking into the subcases. Now, your subcases may not look exactly like that. Your subcases, instead of if and if, might have if and else if. And then it might have a else down here. But the net effect is something very similar to this. And now all I have to do is fill in the blanks. So let's take a look. The first two cases, these two, are pretty straightforward. I have to either return the empty sequence. In the case that the length of t is 0, I'm just going to return the empty sequence. There's nothing to replace. I give you an empty tuple, you give me back an empty tuple. Case closed. For the second one, I need to, instead of replacing the center element with a bunch of other elements, I just need to suture it out. So here's my shot at it. If the tuple has no center element, I'll just return it. I'm not going to change it. On the other hand, if my maximum element t is less than or equal to 0, so I can't use that as a multiplier for the thing I'm going to expand in the middle, then I'm just going to get rid of it and replace it with the empty subsequence. So here I've got the subsequence up to the middle and the subsequence 1 past the middle to the end. And I'm just going to splice them together. So the only reason I wrote this problem with all these crazy conditions, not because it's meaningful, it's a stupid problem, right? But it's forcing you to come to grips with writing index expressions, which was the case in question of the day 3 and the question of day 2. Those were all about subsequence expressions in slicing statements. So those are things that you know are going to be on the test. You need some facility with those. Finally, the last case looks a lot like the second case, except I'm going to put some stuff in the middle. Right here, I'm replacing it with the empty sequence. Here, I'm going to replace it with maximum copies of the minimum element. How do I do that? Well, it's the good old max t times the tuple containing min t. I'm using tuples here if for no other reason to test you on that extra comma. How many of you had trouble with the extra comma in the tuple? Absolutely. You're lying. Most of you did. Only a few of you raised your hands, but you all had trouble with it. This is a stinker right there. But remember the semantics of this. I have an integer, the maximum value of t, and I want to put a tuple that contains the minimum value of t, but that's one element. So to avoid these things being algebraic parentheses, I need the comma. And I'll confess to you, as I sat down and wrote the Lab 2 problem solution, which I do when I write the problem, I forgot the comma. It's inevitable. But if you see this enough, when it happens, you'll say, I forgot the comma. And you won't sit there and think, the Python compiler is broken, right? There's nothing wrong with Python. It's a comma because a tuple of one element needs a comma. All right, let's see how it works. Subcenter, all these elements are less than 0, so what should happen? I get back the center element replaced with the empty tuple. What about subcenter of one element? What should I get back? Well, that center element, the maximum element here is less than 0, so I'm going to take that center element and I'm going to get rid of it. So I get the empty tuple. What about this one? Well, I'm going to take that center element and I'm going to replace it with max copies of min. So 1, 2, 3, 4, 5. Happens that the min is the center element. So the center element's still there, but now there's 5 copies of it. Okay, so this one combined a lot of little things. The tuple with the comma, using max and min to extract elements, reconstructing tuples with concatenation operations that we've been doing since day 1, and some indexing. So I kind of expected a lot of you to get this one right, and I did a brief glance through, and it looks like, I'm going to say 80% of you got this right. And more than that got the first one right. Where things really went to pot, though, is with the last problem. So this is an insidious little function. Explode Lij takes a list L and modifies it so that the ith element of L is replaced with j copies of the ith element of L. So this is a lot like the other one, except instead of working on the center element, I'm going to work on a specific element and I'm going to replicate it. But the key thing here is, first of all, you'll notice I'm using lists. And I'm using lists because we all know that lists are mutable. Tuples and strings are not. So with tuple strings, and sometimes with lists, we construct new list structure by splicing list structures together. We're not doing that here. We're actually performing surgery on the list L. We're changing the list L. So modify, not construct a new sequence. Here's my first attempt. I know from my reading about lists that lists can be list slices and list elements. We saw this in class the other day. Can be on the left side of an assignment. So this says, take the slice that starts at element I and runs to element I plus 1, so that slice of one size. Now notice that slice is different than just the element I. The element I is the thing in the ith position. The slice that starts from I and goes to I plus 1 is the structure containing that thing. So I'm going to replace that subsequence of size 1 with j times that subsequence. That looks pretty straightforward to me. This should probably have been, if you've done the reading, this will probably have been your first attempt with a great start. But unfortunately, when you try it, it throws an invalid syntax error. That seems weird. The answer is, notice what I'm doing. I'm returning this, the result of this assignment. But what do assignments return as their value? We just did this on Wednesday. Assignments, they assign a value to the left-hand side variable. That's what we're doing here. That value goes into, so this now has a new value. But what does the assignment statement return as its value if you were to type it into Python? None. It doesn't have one. Does not return a value. So when I try to say return this statement, the invalid syntax error I get is because return says, I don't know what you're trying to return. There's nothing there. Can't do it. You didn't give me anything to return. So here, for once, for the first time this semester, what are we, week 3, end of week 3? You finally get to have a statement with an assignment in it. And not only is this not superfluous, you need to do this. So those of you who have written all the other questions today with 6 assignment statements and then a return, and I said, why are you using the extra assignment statement? Here you need it. Because we want to do violence. We want to change this L. We want to mutate the L. And then I want to return the new value of L. Assignment does not return the new value of L. So this lets me do the 2 things I need to do. Modify first, return second. So let's take a list, 0, 1, 2, 3, 4, just for kicks. I type that into Python and I get back immediately a prompt. There's no value returned here, no print, nothing. The assignment doesn't have a value. And I try my explode L25. 0, 1, 2 takes this part of the list and replicates it 5 times. So I should have 5 2s in there. And wow, look at that. 0, 1, 5 2s, 3, 4. The value I return is that thing. And more to the point, if I now type L to Python, L is different. I really did change L. Now in the autograder, when I run this, I test to see that you return the right thing, but then I also test to make sure you modified L, because some of you returned basically a spliced up expression of L. You constructed a new list. And the old one would not have been modified. So that's a gotcha. So here I'm really changing L. It no longer has this value. It now has this value. All right, all's fair and good. It looks like I'm done. But I tried another example. Explode L minus 110. Now you might think, remember L is different. L minus 1 is this 4. So you might think that this should give me all of this with 10 copies of 4. Right? It's kind of what I'd think. Unfortunately, it returns an unchanged L, and in fact doesn't change L. So what the heck happened here? I have a nice, simple, clean semantic semantically clean, one assignment to change the list, and then returning the list as a separate step. Everything should be straightforward, and it fails. And moreover, it only fails for -1. So not all indices are created equal. It works fine for -2. If I said explode -210, would have been peachy keen. Just -1. So consider what happens when I is -1. I'm actually replacing L -1 to 0 with J times L -1 to 0. Because this 0, -1 plus 1 is 0. Look at the code. I to I, -1 to -1 plus 1. So from -1 to 0. And this subsequence expression here doesn't have a third argument. So the implicit third argument, the increment, is going to be what? Be 1, positive 1. Implicit. So this says go from -1 to 0 by positive 1. But here's where Python kind of throws a left, out of the left hook at you. The 0 is the leftmost element in Python. -1 is the rightmost element. So using a positive increment, even though -1 plus 1 would ostensibly give you the wraparound behavior, in a slicing expression, you don't wrap around. You can't go from the right-hand side and increment and come back on the left-hand side and consider that a slice. It's disjoint. Here's a story I hope will help you remember this. Anybody ever play the game Machiavelli? It's a card game. Anybody ever play this? So this is a game we play a lot. It's kind of a rummy kind of game. It's quite nice, actually. I'll give you the rules at some point if you like. But my 94-year-old mother is obsessed with Machiavelli. She used to play it with all her little old lady friends until they pretty much all died, and she's alone now. But she always wants to wrap around Jack, Queen, King, Ace, 2. And in the rules of these games, you can use the ace either as high or low, but not both. There's no wrapping around here with increments and slices. And that's what got you stuck here, because you wrote the code for any I to I plus 1, not thinking that when I is -1, I plus 1 is 0, which is a wraparound value. And that fails. So we got to take that special case into account. We can see this because when I say -1 to n, the default is to the length L. -1 to 0, the end is now at the left, so start is greater than end. You get nothing. -1 to 0 by -1 gives you the list reversed. So the default value here, or what happens when that's 0, is not what you expect. Was that mean? You bet it was, but you won't forget it now. Slices don't wrap around. So what's the fix? Well, I'm using an if statement. If I happens to be -1, I'm going to explicitly go from I to the length of L. In every other case, I'm going to go from I to I plus 1, and this works just fine. Thank you very much. No problem, and L has been changed. Okay, nobody gets these all right. There's not going to be one student in this class who gets all the questions that they write and all the labs right. That's because they're challenging, and they're challenging because that's how you have to learn. The best way to learn is spend some time on these. Don't leave it to the last minute. Start it right away. Visit it many times. Write your own test cases. Play with it in the Python REPL. Make sure you understand how it's working. Ask yourself, what happens when it's -1? What happens when this is 0? Coming to class certainly helps. Watching videos online at 2 times speed is not the same thing as coming to class, but I'm preaching to the choir. You guys are here, right? So good for you for coming to class. It's half the battle. It's fine to go look at the videos again, and I hope that you do, and I know that some of you are because I can see the statistics. But, if you're staying at home and you're seeing this video now, and I'm talking really fast, much faster than I usually do, it's quite the trick. That's not the same thing as coming to class. And it's going to suffer. Your performance will suffer. So ask for help. Attend office hours and supplemental instruction. attend, contribute to Piazza discussions. I do have one mea culpa here, an apology. Apparently, Razine's office hours, the Zoom link is broken. The student just told me last night. It's been broken all semester. So I wrote to Razine, I'm going to verify the Zoom link and correct it on the page. Otherwise, you should all be using these. Can you get to office hours? People going? Yeah? Good? Okay. Supplemental instruction. I had a student ask where it was again. I posted a map on Piazza. When you go in the Union, you go down the steps. Java House is on your left as you go down. You know where I am? You go to the right. It's right there across from Java House. But more to the point, for those of you who are anxious about your grades, and I get that, everybody is, it's not really helpful here. The question of the day is, after I drop the lowest 30%, it's like 20 questions of the day, let's say 21, you get 7 zeros, they don't count. Those are only 5% of your grade. And the labs, after I drop the lowest 2, which is about 20% of the labs, that's only 15% of your grade. And there's 14 labs or something, 15 labs. So you have plenty of time to worry about your grade. Worry now about doing the best you can, turning them in on time, getting them in before the end of the deadline. And if you don't get them right, really understand where you went wrong. Don't just think I'll get it right the next time, because you won't unless you try it. You all have copies of the stuff you upload. You can download your originally submitted solution from the icon. I suggest you try to solve them again. Look for other constructs to solve this problem. See if you have other solutions that you can craft. Okay, enough of the sermon. Let's move on. We were talking about print last time. Any questions about the lab? You get them back before lunch, surely. Okay, print is a function. One other thing. I made an offer that said if you could tell me why your file didn't load in Python and you got a 0 because it was ill form, to correct it and send it to me. Silly me, I forgot that ITS strips attachments that end in .py, as some of you have pointed out when you tried to do this. So in the feedback for Lab 2, I've given better instructions. And this is not an open-ended offer. I'm going to do this only until people get a little bit more familiar with indentation and stuff. What you'll have to do essentially is zip the file up in a zip file and send that, because ITS in its infinite wisdom doesn't see zip files as a threat, but Python files are. Don't ask me why. So, and I've clarified a bit, and I'll post that on Icon today too. So if you're trying to send me questions today too, hold on until you see the note on Icon today about what to do and how to turn it in again. Okay. So print is a function that evaluates its arguments and interprets and formats the values for output. Just like assignment, it doesn't have a value. Unlike assignment, it actually prints something out which can be a little bit confusing. So x comma y equal this tuple, x will have value 3, y will have value 4. There's no value returned. If I print this tuple, each element of the tuple will be evaluated. So x times 2 will be 6. Y is 4, and this is a string. They'll be evaluated, and their printed representations will be spliced together and produced on the output line. Notice that print flushes the quote marks around the string and just produces the string directly verbatim. It evaluates these expressions and just adds them, and the commas that make the tuple of arguments result in a space between elements. You also notice that print, like return, is a function that can take as many arguments as you give it. It basically takes tuples of arguments of arbitrary length. So I can print one thing, or I can print a bunch of things separated by commas. If I try to print just one thing, it will flush those quotes, the string, and appear just like it did here. If I type "this is a test" in quotes, the Python REPL doesn't actually print the printed representation of the string. It prints the value of the string. So these are different. So let's compare. When I ask you to print this string, Python reads this statement in the read part of the REPL. It evaluates it. The evaluation produces no value. Prints do not produce a value. But they do have a side effect, and the side effect is to take the thing that it evaluated and produce a printed representation of it. The printed representation of a string loses the quote marks, and the tabs become real tabs. On the other hand, if I type the string to the REPL, this is just a Python object. The read eval print loop reads it in, evaluates the string. The string has a value. The value of the string is the string itself. Python will print that value using its preferred single quotes. And the value of this evaluation is in fact the string. So these two statements are not only look different, they're very different. Here no value is returned, here a value is returned. Even though the output looks similar, the outputs come from different places. This is a side effect, this is a side effect of the print function. This is the value of the expression. This distinction throws a lot of, it's hard to sort of assimilate, throws a lot of students off. You will get the hang of it, but remember, print is hinky. We can see this because print returns essentially a none. The REPL does not show that value because none doesn't have a printed representation. So let's do a little thought experiment here. I'm typing a tuple to the read eval print loop. There are two values here separated by a comma. Python will read these. It says, oh, first thing's a 3. The second thing is an 8. And then it prints out the printed representation of each of these, which is a tuple, 3, 8. We've been doing this a lot, so this ought to be straightforward. The read eval print loop reads it in, evaluates it, and prints out a printed representation, and then gives you a prompt. When I say print foo, which is a string, there is no value returned, but there is a side effect of printing foo out. So this looks like a value in the read eval print loop, but it's not. This is the result of the side effect of the print. There is no value printed here. So let's take advantage of the read eval print loop's natural use of tuples and see what happens. I'm going to put two expressions here, a print foo and a value 8. So what does Python do with this? Well, it evaluates these things, and the evaluation of print foo will cause foo to appear here. We just saw that right there. It'll appear here. And then it will return the value of this tuple. Here, the value of this was nothing, so nothing appeared. But when I do this, I see the printed representation of foo that the print statement produces. And because I have a tuple and one of them, and they're not all none, Python has to figure out how to tell me that this thing is 8 without making it look like this thing is 8. So it gives me back a tuple where it makes the none explicit. Remember this example when you're struggling with the difference between print and return. Print does not return a value. It does nothing except put stuff on the screen. And even though the read eval print loop looks like it's just doing the same thing, putting stuff on the screen, it's not. The putting up the stuff on the screen is incidental to the interactive function of the REPL. But it's actually evaluating and returning a value which is then printed. Those are different things. What happens if I explicitly print nothing? Well, what I'll get here is I'll get the explicitly printed nothing as a line in the REPL followed by the prompt because there was no value returned. So if you can understand this page and know, and it can account for why sometimes I get one line, sometimes I get two lines of what prints and what's a value, you're in good shape with print and values and evaluation. This also explains the handling of tabs and ulines. When it's typed as part of a string with a value, I get back that string with the tab in it. But if I print this thing, the printed representation has the tab which appears instantiated as a bunch of spaces. If I have print of a list that contains strings, one of them that has the tab in it, the printed representation of the list does not include the recursively printed representation of that string. I'm printing a list here, I'm not printing a string. So the stuff in the list is not evaluated. The printed representation of the list requires printing the embedded value, not the embedded result of a print. So I'm printing the outer structure which involves showing the evaluations of the inner objects. All right. So much for print. We're on a roll. Then we're going to talk about fancy definitions. Are there questions about print? Are we good? Look, the best way to learn about print, sit down at the read-eval print loop, print some stuff. Just type it. Get a hang for it. Use some tabs, use some new lines. Use a bunch of spaces. Put some numbers, do some calculations. Print the outcome of an assignment statement and see what happens. So we've seen really simple definitions where the number of formal parameters in the signature explode L, I, J, 3 formal parameters, L, I, and J, are fixed. And we can do some very fancy things with definitions that we haven't seen. So for example, we've seen some functions that take a variable number of arguments or that allow some arguments to be defaulted. The obvious example here is the range function. If I say range 15, the default value for the first argument is 0, for the last argument is 1, so I get range 0, 15 by 1 as the thing I evaluate. You can do this too. When you define your function with formal parameters, you can use an assignment statement to a default value. That means, so we look at this function, it's got 2 arguments, it prints out some stuff, and then it returns the sum of the 2 arguments. It's a stupid function, but there you have it. If I type foo of 3, there's only 1 argument, and I have 2 formal parameters. But the position, that's the first argument, maps onto the first formal parameter, so what I see is that x is 3, y is 0 by default, and the sum is 3. If I give it no arguments at all, I get 0, 0 by default. Now, even if I have default arguments, the default behavior is to map the values in the function call and invocation by position to the formal parameters in the function signature. So when I said foo of 3, when I say foo 3 here, that 3 is unambiguously mapped onto the x. It doesn't go to y, it goes right to x, because the position ordering matters. But it turns out we can fool with that too. If I wanted to pass a value for y without passing one for x, I can do that by invoking this foo with what looks like an assignment. It looks like I'm assigning 7 to y. And that's a useful mnemonic, but it's not actually what I'm doing. What I'm doing here is I'm telling the function invocation mechanism that, yeah, I'm only giving it 1 argument. And instead of mapping it by position onto the first formal parameter, map it onto the formal parameter called y. So with the use of default values in my parameter list, in my function signature, and the use of these mnemonic indicators at passing time, I can basically provide any combination of arguments to the function in any order that I want. Now, that doesn't make your code particularly readable. It can be misused, but it's also incredibly handy. So remember, function definitions in Python allow for argument reordering and mapping of your arguments to different formal parameters than just by position. Now, I mentioned just briefly before that some functions, like print, take more than 1 parameter, and in fact can take 1, 2, 3, or more. There's no limit. In our function here, this foo function, I can still take only a maximum of 2 parameters. I can take 0, I can take 1, I can take 2, but I can't take arbitrarily many. But in print, I can have a lot of parameters. As many as you want. So I need a way of defining a function so that I can have an argument, a formal parameter that gets mapped onto the tuple of all the remaining thing values that I hand you. And the way we do that is with something called the star operator. This is not multiplication. It's a unary operator. It's like a like the unary minus. It comes right before the parameter name. And basically what this says is when I invoke foo, the first parameter will be mapped to x, the second parameter will be mapped to y, and any remaining parameters will be mapped to this argument. So with no excess arguments, I see that the args value here is just the empty tuple. But if I give it 2 extra arguments, I see that those 2 extra arguments are not just not first-class parameters. They are mapped to a tuple that has this name. So you can imagine now that I have, a function that only has a parameter list star args that just gives me a sequence, a tuple of all the values I pass it. And now if I have a implicit print, some sort of built-in printing function, or I want to add 1 to each one of these or something, I could use a map statement to map over all the parameters. Question in the back.
Can you get it to give you a list instead of a tuple?
No, the default is it's going to give you a tuple. But, there's no reason that you can't say list of args here if you want a list, right? The moving back and forth between types is just a function call away. Okay? What about this? Well, range 10 is returns a data structure, right? So function returns a data structure, so the constructor for an object. Takes 3 arguments, I'm giving it 1. By default, that 1 argument is the end, and start will be 0. So this is the same as range 0, 10, 1, which returns a range that corresponds to the number 0 through 9 inclusive. I'm going to take that, and I'm going to use the asterisk operator here to sort of explode this thing. And what I get is the numbers in this resulting range now are exploded, and the first one is mapped to x, the second one is mapped to y, and the rest of them are mapped to the tuple called args. So I can use this asterisk in the signature of the function to say collect any excess arguments. Or I can use this asterisk in the calling procedure here to say blow this thing up and map it accordingly to the arguments. It's really useful, right? It is a little unusual, but is very much the same as what happens with the equal sign, because remember here we used equal sign in the formal parameter list to give a default value, but we also used equal signs in the calling procedure to explain the mapping. And here we use the asterisk or star operator in the formal parameters in the signature to indicate something that collects excess arguments. And we use the asterisk in front of a sequence type here, something returns a sequence type, to say, blow this thing up. Instead of taking this thing and mapping it to the first argument of foo, sort of undo that range and map the elements 1, 2, and the rest. Yes?
For the start, do you have to name it args, or is that just like an arbitrary?
Arbitrary name, yeah. Args is it's a holdover from other languages. You name whatever you like. It's kind of nice to have something that evokes to the human reader that you have multiple arguments being collected there, right? I've seen people use remainder, but that's a lot of letters, right? So args has sort of been my go-to, but you all develop your own style. So notice how that asterisk serves to bust the sequence into individual items, which are then mapped onto the formal parameters. So we've seen today, aside from print, and aside from some nasty functions in Lab 2, we've seen some really cool stuff you can do with Python definitions in mapping arguments and providing default arguments, in exploding sequences and mapping arguments, in using sequence collection for excess arguments, and so on. These things have to become sort of second nature to you. Sure, you can get by without using these for a long time in this class. But in the assignments, in the labs, and the questions of the day, I'm going to say to you, write a function that uses asterisk to collect the rest of the arguments to do this, and so on. All right. This is actually the last slide. We have a minute, so let's do this. You can do the same thing with dictionaries. So I'm going to use the double asterisk here. The double asterisk is this kind of weird syntactic sugar. What it does is it says, I'm going to pass this collection of arguments. They don't really have any names. But I'm going to let the person who invokes this function name them. So how do I do that? So the extra asterisk means that I can use that notation where I name parameters to actually name parameters in the function after the fact. So when I call foo with x equals 4 and y equals 5, what I get back is a dictionary that I can use to look up the parameter name and its value. This is sort of basic function invocation evaluation at its most raw form. You should probably not do this, right? But there's a weird logic to this, and sometimes it's quite useful. And I get as the value of args this dictionary of all the values that were passed, and so on. All right, so I'm going to cover this on Friday. Let's pick this up on Friday because some important caveats there. We'll call it a day, and watch for question of the day 4 after class.